Hello, and thank you for accompanying me today through this lesson on physical and chemical changes. Last time we talked about chemical and physical properties. Now we're going to talk about the changes that happen accordingly. So at the end of this lesson, you should be able to understand the difference between a physical change and a chemical change, and then provide examples of both of those on your own. So really quick, what is the physical property? What is the chemical property? If you need to pause this to answer those, please do so. If not, physical properties are things we can measure with our senses. So I can see, I can touch, I can hear, I can smell. All of those are physical properties. I can see them without anything happening to the substance. It doesn't change. Chemical properties indicate how substances change when combined with other substances. And I can't see these without a reaction happening. So with physical properties, we have what are called physical changes. These are changes to matter that do not change the identity of the substance. For example, we can change the size, shape, or state of matter of whatever we're looking at. We can dissolve sugar in water. We can mow the grass. We can watch snow melt. We can crush a pop can. We can melt ice. We can boil water. We can mix sand with water. We can break glass. All of these are examples of physical changes. But how is dissolving sugar in water a physical change? Because I don't have sugar anymore. I lost my sugar, didn't I? It disappeared. So can I get the sugar back is the question. If I have water that has sugar dissolved in it, I have sugar water here, how can I get my sugar back? And so one of the ways we can do this, we can put this water on a burner, on a heater, on a hot plate, and we can evaporate all of the water out, which will leave a bunch of burned sugar down at the bottom. So it's not going to be fun to clean up by any means, but you can do it. So that is why dissolving is a physical property, because I can evaporate the water, which is a physical change, which is a change of state's physical, and so that leaves me with a physical change here being the dissolving. I didn't change substances, I just combined them. Chemical changes happen when one or more substances are changed into entirely new substances that have different properties. But then what if I don't know if a new substance is formed? What if they both look the same? What if they're both white? How do I know if something's new? Okay, let's find out. So there are some ways we can indicate a chemical change. So some indicators of a chemical change. One, it may produce a gas. It may stink. You mix two things, all of a sudden it stinks. That's a chemical change happening. That smell wasn't there before. It is now. That's a new substance. Two, we form rust. So rust is a combination of some metal with oxygen. So for example, this could be like iron oxide. So rust plus oxygen makes a new substance that isn't just iron anymore. Bubble formation. This is different than dissolving. So when you dissolve something, there's no bubbles. If you put Alka-Seltzer into water, you get these bubbles that come up. The commercial says plop, plop, fizz, fizz. This is the fizz. That means there's a reaction happening. Temperature change. If you mix two substances and they get hot or cold, that is a chemical change. You've mixed two things and you haven't just added heat or put it in the freezer. Those are not chemical changes. But when you mix two things at room temperature and all of a sudden they get hot, that is a chemical change. It may give off light. We can see that. So you light a fuse, that's a chemical change. You watch fireworks, that's a chemical change. You throw gas on lighter fluid, or a match on lighter fluid, that's a chemical change. And sound. So loud noises, any noises. When you mix two things that are not supposed to make a noise and they do, that's a chemical change. If you just hit the desk, that's a physical action, that's a physical change. You didn't change anything chemically. You just vibrated the molecules on the desk with your hand to make the noise. Is this a chemical or physical change here, going from this spoon to this spoon? And you should answer it's chemical because I no longer have just silver. This is tarnished. This is reacted with oxygen in the air. It's different. Is weathering a physical or a chemical change? That's a very good question. So in this case, you can have two answers. So these holes are caused by water. Water which then reacts with the limestone and leaves a gap. So that would be a chemical change. This guy could have been eroded out by water, but was likely eroded out by wind. That would be a physical change. So it all depends on the situation here. Weathering can be both. So that's kind of a trick question. Regardless, when we talk about changes, we have this law of conservation of mass that says the mass of all substances before a chemical reaction is equal to the mass of all substances after the chemical reaction. So mass can't be created or destroyed. But then what about this? Because if I burn firewood, I don't have as much ash as I started with wood. But if I can collect all of this gas that's given off here and take that mass, that would equal what I lost in ashes. So the ashes plus the gas would equal the weight of the wood, the mass of the wood, which is kind of cool, kind of crazy, but kind of cool. All right, here's some review questions. I would like you to give me an example of a physical change. I want to know a couple indicators of a chemical change, and then what does the law of conservation of mass say, and why is that important? Thank you for joining me today. I look forward to continuing this unit with you, and let me know if you have any questions so we can clear things up. But for now, enjoy the rest of your day, and I will see you later.